Good afternoon, everyone. It's Dr. Bennett here. Welcome to Lab 0, which is an introduction to and expectations for report writing for ME314. So, of course, we've had to cancel a number of sections of lab this week because of the snowy weather. But I'm going to cover everything that we would have done in the virtual labs in this video. So I'm going to cover good and bad techniques for report writing, some things that you should definitely make sure that you include, some things that you should definitely avoid as well. I'm going to give you also some examples from previous semesters as well. So let's get into it. Alright, so lab report guidelines and best practices then. So the first thing that we need to discuss is how the lab reporting process is going to be structured. So the pre-recorded videos are going to be released in two sets. So initially the first video set will be released. In these videos we're going to introduce the basic concepts of the lab, describe the equipment and discuss the experimental setup. And based on that video set, you will complete what we're going to be calling prediction worksheets. So these are kind of designed to get you thinking about what to expect when we conduct the experiments themselves. So based on everything that you've seen in the kind of introduction videos, make some calculations about what you're going to see in the experiments, make some observations so that you're able to when you see the second video set, you're able to kind of make and draw some comparisons as to whether that followed your prediction or there were some reasons why it didn't quite follow what you were expecting. So the prediction worksheets are going to be worth 30 points each, and then the following week the second video set will be released. So this is where we perform the experiments themselves. We'll gather the data, we'll provide the data to you on spreadsheets, and based on those videos you will write your final lab report. And this will be worth 70 points, so that will make a total of 100. And later in this presentation we're just going to discuss the criteria for writing what we're going to call a memo report. And in this document you will discuss and describe findings of the experiments, compare it to what you expected and what you predicted from the prediction worksheets. You're going to analyze the results and present the data in the form of graphs and tables and basically discuss what happened in the lab, whether the results are as you expected, what went well, what didn't go so well, and basically put a report together that encapsulates everything that you found in the lab. So, how to write a report then? So just put together some bullet points and some guidelines on what makes a good report. So the first thing to discuss here is the objectives of the report. So of course we're trying to convey some information and convey some analysis of the results. So it's important that we use clear, concise language to convey, to get your point across. So don't be ambiguous in your language. Remember your target audience. Remember it's a technical document, so the language in it that is going to be formal and to the point. It's not going to be wordy and ambiguous. And think of it like you're archiving what you've done in the lab, right? So you've performed an experiment, you've gathered some data, you've analyzed that data, and you've made some conclusions based on the results. So in the industry setting, this type of report could be used as legal proof of support of your findings, and may even be required for if you've invented something, for example, a patent application. So all of this is very important stuff, and it will prepare you very well for the outside world should you decide to go into industry. So, some advice then of the type of language to use when writing your lab reports. So the first one here is probably the most important for me anyway. Be clear and candid in your explanations. So it's important that you tell the truth and don't try to cover up any mistakes in your work by using fancy words or phrases. Be candid, and if something went not to plan, then it's worth more to us as the instructors for you to describe what didn't go well and how you would potentially fix it if you conducted the lab again, than for you to try to cover up your mistakes. So please don't be afraid to tell the story of what went wrong and how you would fix it. Obviously that's a bigger learning point to you and to us for you to say how that you would fix those issues if you repeated the lab. The next point on this slide here, be concise. You will see in a moment when I show you the template for the memo report that there is a page limit. So where possible, consolidate your arguments, make them as concise as possible. Don't go rambling on into wordy sentences and phrases. Try to get your point across as concisely as possible. A couple of other things to point out on this slide here. I'm not going to go through all of them. You can read those in your own time. But the final point on this slide here, be conversational. Tell the story. It should read coherently. It shouldn't jump backwards and forwards in chronology, right? It should tell the story of what you did, how you set up the equipment, the process that you followed and the methodology you followed to gather that data, how you analyzed the data, the methodology that you used to compare results and present results. So some advice if you're struggling to organize your paragraphs. It's important that the document is easy to follow from a reader's point of view. So it's useful to kind of separate various aspects of your report into separate paragraphs to organize your results and organize your discussion. So to kind of convey this information as concisely as possible, you might want to use short paragraphs or even bullet points, in some instances, headings to subdivide your report into sections, and just make it easy for the reader to find what they're looking for in your document. So if the reader is looking for a table of results, don't bury it deep in the appendix, for example. If it's a key result, draw attention to it, put it on the front page, and make it easy for the reader to find what they're looking for in your document. So if you're having trouble here organizing sentences and phrasing your report in the right technical manner, then you might want to use a chronological order, cause and effect. So for example, we did this and then this happened. By level of importance, so start with the key results first and then write your report as those results trickle down, or procedural sequence. So all of this stuff, I mean, my advice when giving advice on report writing in the past, particularly when it comes to shorter technical documents, is to kind of go and find maybe a journal publication or some kind of technical document that you're interested in. Read a few pages of that so you kind of get into the mindset of the style of the writing, and then start to approach your report with that kind of same mentality. So some advice on grammar and phraseology. Obviously this is a technical formal document, so please don't use colloquialisms, jargon and buzzwords. There's some examples on here. It's not going to look good if you submit a report with jargon and slang terms in there. Please try to be as formal as possible. Again, be brief and to the point. Don't say a bunch of words when you can use one word to say the same thing. Again, this will help with your page limit requirements. One thing to draw specific attention to on this slide here is there under be brief and to the point, the third bullet point there. Don't say a small number of, say specifically how many. The number of times that we see this kind of thing crop up in people's reports, people saying a few, or there was a lot of, or there wasn't many of, or there was a relatively large number of. It's all very wordy and non-specific. If you're discussing a result in that context, put a numerical value on it. Okay? That's going to be very important to how kind of concrete your argument is when discussing your results. If you're discussing a number of something, put that numerical value in the text. Obviously, poor spelling and grammar won't be very well tolerated. Again, it makes it difficult for the reader to follow and difficult for us to find what we're looking for in these reports. So try to make it as kind of from a formal point of view, make sure that the English in it is good too, and not just the science is accurate. Make sure that the English is good too, so that it's easy to follow and it's an easily read document. Don't be wordy and weak. So construct your argument and your discussion of your results in a confident manner. So don't use phrases like "it appears that," "we trust that you," "it seems to be the case that," "in my opinion." This is a technical document, right? So you're presenting a series of facts. So use the corresponding language for that, right? So present your argument in a way that you're confident in what you've done, confident in the analysis that you've made, confident in your comparisons, and use the appropriate language for that. So we as instructors and the readers of your reports, we're looking to be convinced that you know what you're doing, that you've done all of the calculations correctly, the comparisons and the results that you've drawn from those are accurate, and your presentation is displaying a series of facts. So please don't use that kind of language that will create doubt in our minds. All of that stuff will mean that we end up with the impression that you don't really know what you're doing. So be confident, be to the point, and present facts. It's useful as well to use an active writing style, again, because it shows that kind of from your personal point of view, you know what you've done, you followed a progression. So stuff like saying a structural analysis of the aircraft was performed. So we performed, instead say we performed an aircraft structural analysis. So you're writing it kind of from the first person, you're saying what you did from your point of view. So again, that allows us to gain confidence in the fact that you know what you're doing, that you followed a strict methodology, and we're gaining confidence in you as the report writer. So, as I said, there's going to be a template for you to use for the memo reporting format. We have a template that we're going to upload to Canvas in a Word document format, which we're going to discuss now. But please pay particular attention to what should be included in the various sections of your report. So in the discussion and analysis section, we'll get onto this in a moment, but that's where you should describe and compare your results. Then any of your key results that I should know as the reader should be presented in a nicely drawn graph or table that draws my attention to those key findings. And there should also be proper formatting for every sample calculation. So this is the first page of the template. You'll notice that the headings is very simple. There should just be both of your group members written at the top, name and title of the lab, and then the date. You'll notice also that there's no abstract because this is a very condensed style of reporting, right? So we're going to do away with the abstract and go straight into a discussion and presentation of the results. So this part of your report should be no longer than 2 pages. You should use a style and tone that we've just discussed, right? And in general, you shouldn't go into too much detail regarding the methodology and process of the lab, because obviously we've performed that for you. But if there is some anomalies or something that you don't think was conducted correctly, or something that could have been improved on that's pertinent to the results, say there's an outlier in the data and you've noticed something that we did in the videos that could have led to that, then of course you can draw attention to that. But in general, you don't need to go through step by step of how the lab was performed. This final paragraph here in the first section is extremely important. You must display a very high level of critical thinking as you present your results. So every time you make a calculation or you make a claim, it's very important that you take one step back from there and put your results that you've just calculated into the context of what you would expect. So there's an example here. If your results imply that an aluminium beam has a modulus of elasticity 100 times the expected value, of course there is a mistake somewhere in your calculations. Now, it's okay to have mistakes in your calculations. If you're really unable to find where the error is, that's fine, but please make sure that you draw attention to it and say that it's clearly an error, that there's a miscalculation, it's way above the expected value, and maybe give some insight into where you think the error might lie. But first and foremost, try to correct your results so that they fit within the context of what you would expect. But always draw attention to something that's way out of the boundaries of what you predicted in the prediction worksheets. So some advice on presenting graphs and tables. So obviously these should be very easy to interpret, and they should be condensed as well. So for example, I don't need to look through an Excel spreadsheet of all of the data. I expect you to condense that data down into something that's maybe 4, 5, 6 lines long, that shows me the key results and basically the outcome or conclusion of your analysis. So if it's an important result and I should be able to draw some comparisons from the table, please make that obvious to me as the reader. Graphs should be well labeled. They should have a complete and readable legend, captions, axis labels, units where appropriate. Also, you can include a title or a figure number so that you can refer to it in the text. And error bars are also required on all graphs. Similar kind of requirements for a table. Obviously they need to be well labeled and with units where appropriate. And this idea here of using an appropriate level of precision, think about the number of significant figures that you're presenting, right? So clearly it's not appropriate to present a result to 15 decimal places, okay? It's a bit of a bugbear. As a general rule, don't provide more precision than the original device gave to you. So for example, if you're reading a voltage from a DMM that has 2 decimal places worth of precision, and then you make a calculation that spits out a number to 15 decimal places on your calculator, it's appropriate that you then round that to 2 decimal places because that's what the original reading was given in. Okay, so on the next page of the template you will find some advice as to how to lay out your sample calculations. As a general rule, every type of calculation that you perform for your analysis needs one sample calculation, just to show us that you have used the correct formula, that you've inputted the right values, you've cancelled the appropriate units, and so on, and you've come out with a final answer to that calculation. If you just present a result in your report without a sample calculation and it's incorrect, there's no way for us as the reader to verify what you've done. So think of this as a bit of a two-way street here. You're documenting the calculation that you've performed, so you're going to be able to recall that and revise that, how you managed to get that number, and it's also demonstrating to us as the reader that you've used the correct formula, you've inputted the correct values, and generally we're gaining confidence in your results because you've performed the correct calculation, and we can verify that from the sample calculation. So in the bottom half of this slide here you can see what we expect for a complete sample calculation. You can see there a heading telling us what we're going to be calculating. You can see a statement of the formula. You can see any nomenclature described below it, and then you can see the formula written out again, but with your specific values in place of those definitions, okay, with appropriate units as well. So the next step to that is to include the final answer with the final units. So that's what constitutes a complete sample calculation. You may need to refer to tables that you've had to look up online or from textbooks, and then of course you can reference those below the sample calculation as well. So what are we looking for when we grade your reports? So as we've said earlier on in this presentation, prediction worksheets will be worth 30 points, memo reports will be worth 70, taking your total up to 100. And as a general rule of thumb, when we are grading the reports, points will be awarded from that 70 points approximately to the ratio of a quarter for discussion of results and findings, a quarter for the data presentations, whether that's graphs or tables, a combination of both, and then approximately half of those points will be weighted towards sample calculations. So you can see that sample calculations will be weighted extremely heavily in your report, because that's how we gain confidence and verify your results. So when it comes to a discussion of your findings, obviously clear, concise and accurate analysis. You must make sure that you back up any claims and put your results in context of what you expected and what you predicted in the worksheets, right? And then what we're looking for when it comes to the data presentation is clearly presented and easily interpreted graphs and tables. You obviously use these to aid your discussion. You can refer to them in the text. And as a general rule, if you're presenting a graph or a table, tell me as the reader what I should be deducing from your graph or table, right? Tell me what I should be seeing in your graphs and tables. And please don't include graphs or figures or tables that don't add value to your report. So of course, you're limited to 2 pages worth of text for your memo report, but then if you would like to attach graphs and tables in the appendix along with your sample calculations, you can of course do that, but don't include anything that's unnecessary. It just makes, again, finding what we're looking for harder, because you're burying important results within stuff that's not necessarily required. And then sample calculations, as I said, will be worth approximately half of your memo report grade, and these are required for every type of calculation performed. So that's what we're looking for when we're grading these reports. Now let's have a quick look at some good and bad examples from previous semesters. Starting with the good. So what you can see here is the front page of someone's report. You can see 2 very well presented tables. You can see tables are very well labeled. You can see that they've got units where appropriate. You can see that the error or uncertainty in some of these calculations is also included in the tables. You can see, particularly when it comes to the second table there, you can see a nice color coding going on. All of this stuff helps me as the reader focus in on what the important and key results are in this report. You can also see there's some really nice descriptions, stuff like in that first sentence there, the experimentally measured values do not overlap the theoretical values even within the uncertainty. So of course that's a very key result. It's up there in the first sentence. You can see references to the tables in the text, so of course they're adding value to the report as well. And in general, that looks like a well put together report. Everything's labeled, and numerical values again are used in the text, so there wasn't wordy and inaccurate kind of references or phrases. Wherever there was a numerical value to put on an argument, this person put it in there in the text. So that's a good example of something that could be on the front page of one of your reports. Moving on to something that I found in the appendix. This is a very well presented graph here. You can see the axes are labeled with appropriate units. An appropriate scale has been used. You can see a very nicely written legend there. You can see all of the important parts of the curves are labeled. You can see that it has a title. You can see that it has a description above it as well. So you can see my comment there. This is nice. This is what we want to see, right? We want to see clearly presented data in an easily digestible fashion. So a quick look at some examples of some sample calcs. This follows pretty much the template that we showed you just a second ago. So let's take this first sample calc here. It's got a description, so this is going to be the experimental MAC uncertainty. You can see a statement of a formula there. In the text below it, you can see a statement of any of the nomenclature. And then in the second line of the calculation, you can see the formula written again, but with the specific values inputted into the formula with appropriate units. And then you can see a final answer. So again, this is the perfect format for a complete sample calculation, and that's what we expect to see in the appendix of your report for each of the type of calculations performed. Moving on to some bad things. So in this particular screenshot here of someone's report, there's a bunch of things that come to mind. Don't really know where to start, so let's start at the top. In that first sentence there, the one that's highlighted, I can see an unreasonable level of precision in that pound force value given there. Again, it's a bit of a bugbear. Please don't present precision beyond what your original data was presented in. It just doesn't look good, and it's unrealistic. The next thing there that's highlighted, we then plotted everything and got. Clearly that's not the best way to phrase what this person is trying to say there. So please don't use language like that. It's not formal and it's not professional. Then if we take a look at the plot there, which is some discrete points on a chart. Doesn't really matter what the chart is for this particular discussion, but the point here is that the lines which connect those discrete points imply that continuous data was taken when in actual fact discrete data was taken. So again, another bit of a bugbear there. Please don't join dots together when the data that you were given is only discrete points. It's not continuous data, so it's by joining the dots you're implying that continuous data was gathered when it in fact wasn't. So the way to approach this is to plot the discrete points and then plot a line of best fit through the data points. Okay, not simply join the dots. It's bad practice and it's misleading. Okay, let's have a look at a bad example of sample calculations. Again, don't really know where to start with this. First of all, this person has performed their sample calculations by hand on what looks like a whiteboard and took a photograph on their phone of it, but for some reason the image has come out in a mirror image and also upside down. So this is actually a screenshot of someone's report. Clearly we can't assess what you've done if it's such a mess. This sample calculation is all over the place. Not only is it mirror image and upside down and back to front, and it's all smudged and it's illegibly small and it's all over the place. It doesn't follow a progression. There is some attempt at labeling here, 1, 2, 3 I can see, but I mean we really can't follow this type of thing. So again, we're looking for a well-structured sample calculation to verify what you've done so that we can gain some confidence in your results. If your sample calculations look like this, it says that either you don't know what you're doing or you're trying to hide something, neither of which is good practice. So if you would like to write your sample calculations by hand, write them legibly on preferably lined paper, structured, following a progression with a statement of a formula with any nomenclature described, formula again with your values inputted, and then a final answer with appropriate units, okay, and a description of what the formula is as well. If you would like to write all of that stuff by hand, that's absolutely no problem. Make sure you scan it and check that the scanned image is legible. If not, do it again, because again, sample calculations will be weighted very heavily in the report grading. So hopefully that gives you some pointers and some advice on what to do, what not to do in your report writing. As I say, the template for the memo reports will be up on Canvas in a Word format, so please use that. And any questions on this stuff, either ask us in class or use the discussion board on Canvas. So thank you for sticking with me. Dr. Bennett, over and out.